There we go. So sorry about that for those online. Otherwise, now we're back. Anyway, lists are way better than plain old arrays because they can dynamically grow, shrink, change size. You've got these dozens upon dozens of different functions that you can call to do a lot of really powerful stuff on them. The difference between a list and a set was that sets are unordered collections of unique elements. So our attempts to add 40 here twice, or 30 here twice, failed. They didn't fail with an error or the destruction of the program or anything like that. It just that duplicates were not allowed. So once you had 10, 20, and 30 in there, and you tried to add 30 again, it wouldn't let you. It would have no effect on the set. And then we started looking at maps. Maps are the most powerful of these three. Those coming from a Python background will recognize these somewhat as dictionaries, but they're way more powerful than dictionaries. Because with a dictionary in Python, you can only map strings and integers to whatever value you want. With a Java map, you can map whatever you want to whatever you want. So for example, you can map integers to strings. If you want to map an NUID as an integer to a string representing a name. You can also do it in the reverse. You can have a map mapping strings to integers, right? And this would be name to NUID, right, is equal to new hash map. Right? There we go. Well, you could do both of those things in Python, but you can also do, say, map a double to a whatever you want, whatever, let's see. A student, assuming that we had a student class built already. We don't, so let's go ahead and just go with a double, so I got to spell it correctly, double to an integer, right? And I'll just call this foo, hash map, right? You can't do that in Python, can you? You can't map 3.14 to pi or something like that, right? Or map arbitrary objects to arbitrary objects. So in that sense, this map is way, way more powerful. Well, we might get to an exercise today where we're actually using a map to solve a problem. Right? But otherwise, for now, just remember that there are these very powerful data structures that you can use. And remember that one of the themes of the course is that smart data structures and dumb code are a lot better than the other way around. Right? You'll find once you've been introduced to certain data structures, you know when certain data structures should be used because they're super efficient. They're super easy. They make coding something like that would be 200 lines of code. It gets it down to 1 line of code, right? Or maybe a couple dozen lines of code, right? Smart data structures and dumb code are a lot better than the other way around. Right? One thing that Python folks probably have taken for granted this entire time are strings. Right? Remember that we've already covered strings very briefly in that I've told the C folks, those coming from a C background, that there is no null terminating character. There is no memory management. There is no need to call a function to do concatenation and make sure that you have enough room to do anything. Instead, strings are a built-in class. Java has a string class. And it's built in the language package, so java.lang. So it's automatically part of any program that you write. Again, there is no memory management. No null terminating character. For those coming from a Python background, don't worry about it. It's just a technicality. Come on. There we go. Nope. Space, space. Space, space. There you go. All right. Okay. Space, space. Sorry, I'm doing markdown and it's not formatting properly. So basic concatenation is going to be plus. Now something that might be a little bit odd coming from a Python background is, let's go ahead and create a couple of variables here. I'll go ahead and create an integer variable, 10, and then a string variable, b is equal to hello. Right? And then I'll create another string variable here, and I'll go a plus b. Now, can you do this in Python? No, why? What will it be interpreted as? If you've got a plus and you've got a number, that'll be addition. If you've got a string and a string, what will that be interpreted as? concatenation. You can do both of those things in Python. You can't mix the types though. You can't mix a number along with a string, but in Java you can. The way that it works is by simply taking this value here and converting it into a string so that it is interpreted as string concatenation. In Python, what would you have to do? You'd have to explicitly surround this with an str, right? There is no such thing in Java. So undo, undo. It's built into the language automatically. It will run and be perfectly fine here. 10 and then hello. Although you don't have that, I mean, it's, for basic string concatenation, great, but otherwise using printf formatted style formatting is preferred, right? Or it's easier, I should say here. String s is equal to, not new string, but hello. You can do that, but I'm not going to. Hello world, right? There we go. All lowercase there. I want to convert that to all uppercase, and you can do that. S dot to uppercase, there we go. So that will convert, I'm crossing my fingers here because my thought is that it's going to convert that string to an uppercase character. So uppercase H, uppercase E, uppercase L, dot, dot, dot. Let's go ahead and find out if it actually works. Println S. All right, I'm going to go ahead and print that value out. Did it work? It didn't convert to an uppercase character. Why? Those coming from a Python background are going to recognize this immediately. Those coming from a C background, this is going to be new. Strings are immutable, right? Immutable means that they cannot be changed. Strings in Java are immutable. Once created, they cannot be changed. Only new strings, modifications of other strings, can be created. So once I create that string with hello world all lowercase, that's it. That string will never change again. That's what immutable means. The opposite of that would be mutable. Mutatable, right? That you can change it, mutate. And that's what we mean by mutable and immutable. Strings in Python are immutable. Once you create them, you can't change them. You can't change the first character to an uppercase H. You can't change the last character to whatever, right? In C, they're just arrays, so you can change them all you want, unless you put a const in front of them when passing them to a function, but we won't get into that. So what is the point of to uppercase? Well, if you read the documentation here, what does it return? It returns a new string that you have to capture, right? And that will be the uppercase version. I'll go ahead and put that into another variable called t here. Let me run that and show you that indeed the second one that is returned from that function call is actually all uppercase now, okay? So keep that in mind. Strings are immutable. They cannot be changed. And by the way, that's a very good thing, right? Because once you have immutability, you have thread safety automatically, right? In fact, all of the built-in types, string, big I integer, big D double, those are all going to be immutable versions of stuff, right? There is a mutable version. A mutable string version is called a string builder, SB. Is equal to new string builder. And you can change this all you want. You can go do whatever you want with this. SB.append, hello, oops, let's go with HELLO, there we go, world, there we go. And oops, I wanted to go ahead and append a exclamation point to it. SB.append, hello, world, or sorry, append just an exclamation point, that's it. And let's print this out as we're going along. System.out.println, SB. Right? You'll see that it's hello world, and then I've changed it. I've mutated it. I've changed it into hello world cap, or with a exclamation point. But I meant that it should be an uppercase H and an uppercase W, right? So I'm going to go ahead and go with SB.replace, right? The index at which it is treated as an indexable, kind of like a list. Where the first character is at 0, the second character is at 1, the third character is at 2, et cetera, starting at whatever character you want, going up to but not including whatever character you want. Go ahead and replace that with whatever you want. Right? So the interpretation here is I'm going to replace characters 0 through 0, in other words, this lowercase h right here, with an uppercase H. And let's print that out and see what it looks like. There we go. You see that the uppercase H now is there? Making sure that this is viewable on the live stream. Yep, my face is off to the side. Right? All right, that takes care of the uppercase H. How would we replace it so that that lowercase w so that it is an uppercase W? What indices would I have to look at to do that? Well, there's the first index, 0, 1, 2, 3, 4, 5. So starting at 6 and going up to when? Just 6? Let's find out what happens there. Right? So 6 through, we call this inclusive-exclusive. This pattern is followed in most programming languages because of zero indexing. It's always going to be inclusive on the first index and exclusive on the second index. So if you go from 6 to, say, 10, that's going to be 6, 7, 8, and 9 because of zero indexing. Let's go ahead and actually see what that does. Right? So what did it replace? It replaced 6, 7, 8, and 9 right, with a capital W. So I'm just going to go ahead and replace only one thing, right? Is that going to be right? Inclusive on 6, but then exclusive on 6. So what does that give me? 6 through 5. Is that going to have any effect? Let's see what effect it does have. Right? It has the effect of inserting something. Right? Replace nothing with a capital W. In other words, insert a capital W here. So what I actually wanted was 6 through 6. Replace the seventh character here with a capital W. There we go. Now, once you're done building your string, it's a string builder. You build it iteratively, build it and then append it, change it, do whatever you want with it. Then you can go ahead and dump it to a regular old string. String str is equal to sb.toString. And now it becomes immutable. You can't change it now. Right? But you've got a mutable string version called a string builder. An alternative, older alternative would be a string buffer, right? But I'm not going to cover that. One is good enough. Right? So I'll put that in the notes for you. We do have a question online here. Right? We have no, I fixed that in the first 10 seconds. Sorry about that. All right? Okay, so that's strings. What else do we have in strings? All you have to do is go create a string here and say hello world. Right? What else could you do with a string that's already built in? Right? What kind of library functions do we have here? S dot, and you start looking at them and there are dozens upon dozens upon dozens upon dozens. Right? Or better yet, what you can do is you can open up a web browser, right, and look for Java string. Right? Bring it over here. Right? And once we find it, this is Java 7. You could go ahead and change it to Java 19 or whatever. But you can start reading all of the documentation here for all the methods that you have. For example, you can get a single character. It is zero index based, so you can get the first character, you can get the second character, you can get the third character. You can ask whether or not it contains a substring in there. You can get copies of it. You can convert them to bytes. You can do a whole bunch of stuff. You can search through a string for a particular substring. What's the index of this substring, etc. I'm only going to show you a couple of more useful ones. Right? So what I want is, let's see, hello world. What I want is just hello. I want to substring just the first word. So string first word is going to be hello. But I want to pull it out of that other string. So s dot substring. And there are actually 3 different versions of this. There's a substring that takes 1 index, a substring that takes 2 indices, a beginning index and an ending index, and then finally a subsequence, but we'll not worry about that one. The first one is going to have 1 index. That's your starting point, and then it goes all the way to the end of the string and gives you that whole string. So if I want the first word here, I would start at 0, right? System.out.println, first word. And let's see what that gives me. It gives me the entire thing. Why? Because it starts at 0 and goes all the way to the end. If you want to start at an arbitrary index and then end at an arbitrary index, you provide it 2 arguments. I want to start at 0, and it's the same pattern, inclusive, exclusive. So if I just want hello, right, 5 characters here, then would I go up to 0 and 5? Let's find out. Yes. Why? And how do I know that there's not a space there? Well, you hover over this and you see that there's no space. Right? What if I only went up to, well, I only wanted up to 4, right? This is 0, 1, 2, 3, 4. Right? Remember that it's inclusive, exclusive. So if I just did this, I would only get HELL. Right? So I want all of it. I want the entire word here 0 through 5. What about that second word? String second word. S dot substring, oops, substring, right? And where should I start this now to get world? What index is that capital W going to be at? 6? I think it's 6, isn't it? Oh, hello is 0, 1, 2, 3, 4, then 5, then 6, right? But I want to go all the way to the end of the string. So the single argument version of this will work for me. First word and second word. There we go. Hello and world. Excellent. Right. So substrings, really powerful stuff here. One thing that we often have need to do is processing data. And one common format that data comes in is CSV format. So CSV stands for what? Well, let me write some data here, and you can guess it. Here's my name. Here's my office. Here's my department, School of Computing. There we go. There we go. There's my data. There's my name, first name, last name, my office number, and my my unit, my School of Computing, right? My association. What does the C stand for? What does CSV stand for? Hopefully we remember, some of us at least. It's one of the most common flat file data formats ever. Right? If I were to have a CSV file and I double-clicked it, it would open up in Excel because it would give me an Excel spreadsheet. CSV stands for comma, separated values. Right? What I want to do is I want to tokenize that. I want to split that out into the first token, my first name, the second token, my second name, my last name, the third token, the fourth token, etc. If you're coming from a C background, we had to do this quite manually, right? What we had to do was we had to call strtoke, and then we had to be careful because the first time we call it a certain way. Each subsequent time we call it a different way, and then we have to check to see are we at the end of the tokenization, et cetera, et cetera, et cetera. It's a whole big to-do. Here, it's much better. If you want all those tokens, right? Each one of these things is called a token, the first token, the second token, the third token, right? You can go ahead and take that string, CSV, let me call it what it is, CSV data, and I'm going to split it. I'm going to split it along commas, okay? Now let's take a look and see what is in that thing, system.out.println tokens. Now before I run this, you would expect it to be Chris, Burke, my office number, my school, and then School of Computing, right? But that's not what we're going to get. We're going to get this weird thing. What is that weird thing? Well, okay, so it's it's this syntax, and then it's telling me, well, this thing is a string, it's an array of strings, and then we've got this weird hexadecimal thing. Anytime you see a hexadecimal, right, what is that screaming out to you? It's probably a memory address, right? So it's not, just taking tokens and trying to print it out is not going to work. In Python, this would probably work because this is just going to be a list or an array of strings. But a lot of times when you have like a list or an array of arbitrary objects, right, it's not going to nicely print. In Python, what do you use? Do you remember the pprint package? Or have you ever used the pprint package? No? It's a very useful thing in Python. It pretty prints everything, right? So the first P in that is pretty. It's going to pretty print it, right? This is not pretty. This is just a memory address. So to get pretty printing in Java, what we need to do is we need to bring in the arrays collection here, arrays.toString, right? And that will automatically convert this to a tokens, excuse me, to a nicely formatted string that we would expect if we just printed it out normally, right? It's an array of strings. We're going to delimit that. Here's the first one, here's the second one, here's the third one. So anytime that you have an array of things, right, then you need to use arrays to string in order to print it out to the standard output. And you see how it split it, right? I can go ahead and iterate over it. Here's a here's an enhanced for loop for string s in the, I've already used s, so let's go str, in the collection tokens, right? System.out.println str. All right. So that'll print them out one to a line. Okay. What if I changed the delimiter here? There's not just the CSV data. If this were like, say, TSV data, what would the T stand for? T? Tab separated values, right? That's the other common or not so common one in Excel. Otherwise, you can split this along anything that you want. What if I split it along lowercase o's? What would I get then? A bunch of garbage, right? I would split it along my first, the lowercase o in my first name or last name, the o in shore, the two o's in school, at the of, and then the o right here, right? What token is between those two o's there? Nothing. So consequently, what did it get what got printed here? Nothing, right? You can have empty tokens. That's not very useful, right? You're going to want to split along things that make sense. If it's CSV data, then commas. If it's white space, then white space. If you want to split it up along a bunch of white space, right? The equivalent in Python is going to be split, isn't it? You can use split in Python. I think so. Don't quote me on that though. Right. All right. Let's see. I'm going to put this into the notes so that you have it. There you go. Oops. There. Okay, there we go. All right. What else? Methods. All right. So what do we mean by methods? Don't worry about it. In Java, functions are called methods. You know them in Python as Java. You know them in C you know them in Python as functions, and both in C as functions. So why do we call them methods in Java? It's because methods are functions that are inside of a class, right? So methods are just functions inside a class. It's just another name for a different scenario, right? You'll find me misusing and abusing and interchangeably calling them methods or functions or whatever. It doesn't really matter. In C, all the functions exist in the global namespace or in a package or something like that. In Python, all functions exist within a package. They don't have to exist within a class, right? So we call them functions. But in Java, everything is a class or belongs to a class. Consequently, we call them methods instead when they're inside of a class. For now, all of our methods are going to be public static, right? Public static. Right? Public simply means that any piece of code can see them and use them. Static means that they're going to belong to the class, right? What that means is that to invoke or call a function, a static function, you use the class name plus the function name. Right? We've already seen this before, right? And system.out.println. What is the square root of 2? Using yes, you can replace arbitrary characters with string.replace. Right? All right. So what's the square root of 2? 1.41 something something something. Right? The way that I invoked that function, the way that I called that function, is the class name dot square root. Now, because in Java the standard is to use upper camel casing, right? All of our classes are going to start with an uppercase, and then and if there's a subsequent word, that's uppercase, but all the rest are lowercase, right? In Python, the style is a little bit different, but the same idea. You would import math, and then you would use math dot square root, right? Exact same thing. In C, you don't import anything. You include the math library, and once you do, you have access to the square root function, which is not part of a package. It's not part of a class. It just exists, and you call it. Okay. By the way, how do you think it works? How do you compute the square root of something? Anybody take a numerical methods class or a numerical analysis class? Eventually you will, right? It's going to be some Taylor series, maybe some interpolation series or something like that. Do we care? No, that's the whole point of writing functions, right? Once you've written that function, once somebody else has written that function, you don't have to worry about it. Procedural abstraction. But if you're really interested, let's go ahead and take a look. Right? So the square root function actually calls this other square root function in the strict math class. Let's check that out. By the way, what am I doing here to go from one place to another place? I'm holding down, this is a Mac, so I'm holding down the command button, and then things become clickable. In Windows, don't quote me, but I think that it's control. You can hold down control, click on something, and be taken to the code for it. Now, do you see any code actually implemented here? No. This is what's called a native function. The native function is just simply whatever the system is. And guess what that is? C, right? Same thing in Python. What do you think the square root function is written in? It's just the C standard library function that you're using. The vast majority of the stuff that you're using in Python under the hood, it's all C. The interpreter is written in C. What do you think the Java virtual machine was written in? C, 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 over and over and over again. That's why it's such an important language, right? All right, so we've got our math.square-root. Let's make our own functions now, right? So what I want to do is let's go ahead and create a function to do, right? That's another trick, right? If you need to make a note to yourself inside of code, you always make a to-do, right? This is something I need to do. Write a function that takes an no, let's actually do a list. A list of integers and let's say adds 1 to each, right? There we go. There's my to-do. Now, why do we like to-dos here? Right? Because it reminds me that I need to do this thing. But not only that, if you've got a sophisticated enough IDE, Eclipse in this case, most IDEs will do this. Where's my tasks? Oops, I don't have my tasks. So let's go up here to Windows, Show View, and it should be Tasks. There. I just added this tab down here. What are my tasks? Anytime I put in a to-do in a comment, right, that reminds me that that's something I need to do, and Eclipse collects all of those things here. So it's a reminder of, well, in that class that I closed like 5 hours ago, what did I need to do again, right? There's always a note there, and then you can double-click on it and be taken there right there. Right? I need to make sure that I finish this cat class here, which extends animal. We'll talk about that later. Right? Okay. But otherwise, I've got a to-do here. Once I write it, what should I do with that to-do? Once I'm done with it, once I'm doing what I needed to do, what should I do? Get rid of it. Right? I'm not done yet. Right? Let's actually go ahead and write this function. Okay? For now, all of our functions are going to be public static. Right? Don't worry about it. Otherwise, now here's a difference with functions in Java versus, say, Python. You need to explicitly say what type of variable the function returns. In this case, what should our return value be? If I'm going to give you a list, and you're going to modify that list and change it so that you're adding 1 to everything. For example, you're going to say you've got a list here of 3, 7, 4, 5, and 9. I want to transform that into a list containing 4, 8, 5, 6, and I'm having to do math in my head on the fly here. There we go. Was that correct? I think I was correct. If not, please correct me. Right? That's what I want to transform it into. So what's my return value going to be here? If you gave me a list and I created a new list that was a copy of that other list with everything add 1 to it, right? Then I would need to return a list of integers. Integer. Right? That's not what I want to do. I want to take your list, modify it, and then be done, right? So I'm going to have a void function. Void means nothing. What does this function return? Nothing, right? There's still going to be a return statement, right? Just like this main here. You don't have to put in the return, but it is a good practice here. Just return. Return what? Nothing, right? And that's why we've got the semicolon right here. What happens in Python if you've got a function that's supposed to return an integer, but you don't? Then you sit there and you stare at it for 10 hours, not realizing your mistake, right? There's no compiler error, there's no interpreter error. Instead, what happens? What gets returned? N-O-N-E, right? None, right? In Java, in C, if you don't return something and you said that you were going to, then it's going to be a compiler error, or at the very least, a warning, right? So what should we call this function? Add one, because that's what it does, right? Functions are verbs. Functions do things. You should name them after verbs. Variables are nouns. You should name them after nouns. In this case, it's just n. But if I had a list of students, I would say that this is a roster or students, right? This one, it's a verb. It's going to add one to to each element in the list, right? Then I provide parentheses. That's familiar to both C and Java folks. And then within those parentheses, you provide the parameters. I'm going to take a list of integers. Well, what should I call it? I don't know, numbers. That's as good as any other, right? Not integers, but integer. There we go, right? I'm going to take a list of integers, and I'm just going to call it numbers. What's an alternative? Should I have called it, like, stuff? Right? Not really. Should I have called it L for list or list? Those are slightly better, but still icky. Numbers is probably good enough, right? Remember, C folks, what are the two most difficult? There are only two difficult things in computer science. What are they? One is cache invalidation, and the other is naming things, right? So you can go back and forth and argue over what the name should be, right? It's pluralized in this case because it is a list of numbers, right? It's not a number. That's good enough. Move on, right? Stop arguing with yourself. Once you've got something that's good enough, then then go with it. Because what's better than good? Not perfect. What's better than good? See, folks. Good enough, exactly, right? So, good enough. Let's go ahead and iterate through those things and add one to it. Well, let me go ahead and try to use a traditional, or not a traditional, but an enhanced for loop here. So, for each integer, x, in the collection numbers, how can I add 1 to x? I could go x is equal to x plus 1. Or I could go, and then even Python folks will know this, right? Plus equals 1. What's another thing that I could do? Even simpler. Plus plus. All right, let's try that. Return. Now to test this, I'm going to come down here to main. And I'm going to try to call it, first of all, I need a list. A list of integers, right? And numbers is equal to list.of. Yes, I can do this. 1, 5, oh, here. I've got an example up here. These guys. There we go. Here's a really quick and easy way, easy, dirty way of creating a really quick list. Right? Just going list.of. I think that that's only for small lists because I think that there is a limit, like 9 or 10 elements or something like that, maybe a dozen elements. Let's go ahead and print that out, system.out, system.out.println. Remember the problem that I had before, that it would print the memory address, right? But that was with a plain old array, right? Lists are way better than arrays because their representation is built in. 3, 7, 4, 5, and 9. I don't have to go arrays.toString. This is yet another reason to always use lists instead of arrays. Now let's invoke my function. To invoke my function, I need the class name and then the function name. This class is called demo, dot, and then what was it called? Add one. Oops, add one. Okay, and I'm going to pass in numbers here, and then I'm going to print it out again to see if it worked. Crossing my fingers here. It didn't. Okay, so let's come back up here and fix it. So why didn't it work? Am I really playing around with anything in that list? For each integer x in the list, it pulls out x, 3, adds 1 to it. X is now 4. Did I change anything in that list? Nope. And that's why it didn't work. All right, let's try something else. All right. Instead of an enhanced for loop, let's go ahead and go with for int I equals 0, I is less than numbers dot size is how you get the size of a list, I plus plus. Right? Now what I'm going to do is I'm going to get the ith element, oh, numbers, excuse me, there we go. Numbers dot get, right? I. And here I'll try plus plus. Right? There we go. What are you complaining about? Oh, okay, wow. Yep. Get I should be an integer, right? Yeah, it is an integer. Plus plus. Oh, wow, cool. It's not even allowing me to increment y because these are big I integers. All right? All right, fine. So what I'm going to do is I'm going to pull out that number. X is equal to this. I'm going to that, or int x. There we go. And then I'm going to go ahead and increment it. And then I'm going to go ahead and put it back in and replace it. Numbers dot, what is it, set. Set the element at the index I to this x. There. That's this is a quick and dirty way of doing it. Right? Let's go ahead and see if that worked. Exception. Oops. Immutable. Oh, darn it. It did it for other reasons. New array list of integers. There we go. The of syntax gives me read that word right there. Immutable. Where have we heard that before? Strings. Strings are immutable. They cannot be changed. If you use list.of, it gives you an immutable list. In other words, a list that cannot be changed. If I try to remove an element and then replace it, right, change it, then it's going to throw this exception here. Right? Now, what I've done here is I've wrapped it around a mutable list. Don't worry about it. We'll talk about constructors later on. And this should work. Yay. It worked. Right? Now, I'm changing your list. What is an alternative? Actually, before we do that alternative, let's talk about documentation. Every non-trivial function, every class needs documentation. For your first assignment, we're looking for, at a minimum, author documentation, right? A description of what this class does, right? Or what its purpose is, an author, a date, right? That's really all you need, right? Don't throw away the 2 or 3 or 5 points or whatever it's worth just by simply not putting your name on it. Right? If you're in an English class and you handed in your essay without your name on it, are you going to get graded? No. Same thing here. Put a header documentation on this. Likewise, every non-trivial function, by the way, main is a trivial function. You do not need to document it because everybody knows what main does. It's the main function. That's the starting point of the program. But this one does. This needs documentation. Right? Adds 1 to the to each element in the given list of integers. Right. There we go. That's it. That's all you need. Right. Give me a plain old English description. Now, why do we use this this doc style comments? / ****, you'll see that it's in blue. Right. If I hover over this, you can see that it's auto-generated all this documentation. Remember when we looked at the string documentation over here? How do you think that that was generated as a web page? They were using doc-style comments. They were linking between different documentation, linking within the same document, because you can use integers. There we go. What is an integer? C href equals, and then I'll come back to it, Wikipedia. There we go. You can do really sophisticated stuff like Wikipedia integer. Like connecting to an external resource like Wikipedia here. What is an integer? Well, it's a whole number, zero, including negatives, etc. And when I hover over this, hey, cool, it's hyperlinked now. And I can actually click on it, and it'll open up. The way that I've set it up is it'll open up in my default browser. By default, I think that it would open up. There is a browser in Eclipse built in, because if you want to do web development, of course, you need to preview your web page that you're writing in code. Right? Otherwise, you can use arbitrary HTML if you know it. Right? Not that you'll have need to, right? But if you want to, link to your web page or something like that for your author documentation. It doesn't matter. What's an alternative here? Instead of changing your stuff, what I could do is I could take your stuff, create a new copy of it with everything added to it. Let's do that version instead. Public static void, or instead of void, it's going to return a list of integers, integer, right? And it's going to have the exact same signature as up here. Add 1. There we go. All right. Now, before I even write this code, am I going to be able to name these two things the same? No. You do have what's called function overloading that we'll talk about later on, where you can have one function, 5 functions with the same name, but they have to at least differ in their parameters, right? So what should I call this one instead? If I'm going to make a copy of your list with 1 added to each element, what would I do? Or what would you want to call this instead? Add 1 copy? Right? Copy of add 1, right? Doesn't really matter. So let me go ahead and create a copy of that list. List of integers, integer, right? And this will be my copy, new array list. And before I was creating array lists like this, what you can do is you can take this and you can put it in here. And what that does is it creates a completely new, different, deep copy. We'll talk about details and deep copies later on when we come back to this on Friday again. But I do want to finish this out here today. Right? I'm gonna steal my documentation on this. Actually, no. I'm gonna write it anew. Right? Creates a new copy of the given list of numbers with 1 added to each element. Returns the new copy. There we go. Oops, there we go. All right, so there's my copy. Now what I need to do is I need to go through and pull out each element, add 1 to it, and then put it back into the copy. Gee, sounds like I've already solved that problem, haven't I? Okay, I'm going to go ahead and cut and paste this and put it down here. And instead of numbers, it's going to be copy, copy, copy. Should I have done that? Should I have cut and pasted code in the same class in the same instance? No, we call that copy pasta. Copy pasta leads to spaghetti code. Spaghetti code is bad because, like spaghetti, you can't tell one noodle from another, right? It's a huge mess. DRY, don't repeat yourself principle. DRY principle. Right? What should I have done instead? If you've already solved the problem of adding 1 to a given list of numbers by putting it into a function, what should you do? Demo dot add 1 to the copy and return the copy. Done. This is why we write functions, so that we can use them. If you're writing functions and not using them, you're doing it wrong, right? If you are writing functions to replace what's built into the standard libraries, right, you're doing it wrong, right? By the way, for those of you coming from a C background, I will give, how would you have done this in Python if you just wanted to add 1 to a list? No? All right, new list. I'll say, this is Python code, this is not Java code. X plus 1 for X in numbers. Right? That's not real, obviously it's not going to compile, but that would be really nice Python. Why? What is that called in Python? A list. Oh, hopefully we didn't do comprehensions. Oh God, okay, never mind. Those coming from a Python background, you were shortchanged. Go back and look at comprehensions, list comprehensions, dictionary comprehensions. That is the fundamental tool in Python, rather than, you rarely ever want to write an actual function in Python. That's not the Pythonic way, right? Those of you coming from a C background, wow, look at that. That's really cool syntax, isn't it? I can create an entirely new list without having to write an actual loop. Instead, the loop is embedded in the command to do something. What is this? It's all X plus 1 for X in numbers. It creates a brand new list with 1 added to everything in a single 1 line of code. Right? List comprehensions are super, super powerful. Dictionary comprehensions are even more powerful, and that's the Pythonic way of doing stuff. Right? If you want, I can post a primer or at least a tutorial on list comprehensions, but don't worry about Python in this course. Right? All right, questions? Oh, by the way, did it work? Let's find out. List of integers, copy ones, all right, is equal to, again, it's difficult to name things in computer science. What do I name that variable? Copy, fine, right? And let's go ahead and put in numbers. Remember that numbers would have been added 1 already, right? and then system dot, so it's going to end up adding 2, right? And copy 1s. Let's make sure that it works. There, 5, 9, 6, 11, and 12, or 11. I'm going to prove to you that it's actually a copy. Copy 1s dot, I'm just going to clear it all out. I'm going to remove everything in that copy. Is that going to affect the original numbers? Hopefully not. If it's a true copy, numbers would not be, oops, let's go ahead and print out both of them. You'll see that copy 1s is now empty. There's an empty list. But the original numbers, which was 4, 8, 5, 6, and 10, are all the same. We call those deep copies. Shallow versus deep copies. We'll start there on Friday.